Hey everybody, today we have an intriguing problem that involves the definition of a new operation, a different type of multiplication. So we do have to assume that AB, the real values AB are not equal to 0. This came from, I think, a Carnegie Mellon math competition back in 2017. But again, we define multiplication to be the product over the sum. So this new operation is not multiplication in the traditional sense. It's this product over sum. And so you can see here we got this horrible looking problem of nested operations all the way out to 2025 in base 3. And our task is to evaluate this. It's almost always some type of algebra is going to help you out here. So what we do is we look at just a pair of terms under this new operation and we reach this simplifying algebra. And again, the standard trick here is to multiply through by 1 in a clever way. A thing over a thing is equal to 1, right? So this particular multiplication by 1 results in a simpler looking expression for our new operation. Okay, this looks somewhat like the harmonic mean, not quite the same thing, but so this is what happens when you pair up two real numbers under our new operation. And so if you take a look at this form, it's a nested situation here where it would almost be unwritable if you don't use the ellipsis, And so it makes sense to determine what happens when you combine 3 in this fashion, which is what this evaluate statement indicates. Okay, and again, a little bit of work here to go through this. Most of the work in the problem is actually right here. And again, I won't go through all the details, but we get that 3 of them combined in this parenthetical fashion gives you 1 over the sum of the reciprocals, okay? And we'll take an inductive leap of faith here and apply that to our problem, okay? Instead of, if it did it for 2, it did it for 3, so we're going to assume it'll do it for as many as you want, okay? And so here we go. So far, so good, and we've evaluated it in some sense, but there's some simplification that we can avail of here. You'll notice this bottom part is just a finite geometric series. And so what's going to happen, I'm going to multiply through by 3 times 2020, 3 raised to the 2025. And we'll get this right here, 3 raised to the 2025 in the numerator. Multiplying the numerator and the denominator by 3 raised to this ginormous number. Now you'll see the pattern that's going to prevail right here. And I'll write it in the very same order. It'll be kind of backwards looking. But this very first term would be 3 raised to the 2024. Just laws of exponents, folks, right? If I tap this thing with, this is 1 to the 3 to the first power, right? Over. Okay, so you get this 3 to the 2024 right here. And then the very next term would be 3 to the 2023. And hopefully that's you see the pattern here. The next one would be 3 to the 2022. But the very last term would be 1, which is makes this easily recognizable as a finite geometric series. So I do the ellipsis into 1, folks. And I would like to show a bit more, but I got the space problem here. So anyway, this is equal to this, and this bottom part is a finite geometric series. Now let's come down here where we have more space, okay? And it looks like I already did it right here. Okay. All right. Well, anyway, yeah. Well, I just did the work, and I did include some more space right here. But y'all notice what this is equal to. Let me get the pen working again. That's another thing that fails miserably when I switch like this. Okay, let's see here. There we go. Let me get this working, folks. Sorry. Is that working? Yeah, it's working. All right, so y'all, what this is equal to is 3 raised to the 2025 power. And this part right here involves summing. The bottom part is just a finite geometric series. Okay, so this, if you've seen how this goes, it's going to be the first term. Okay, the very first term is 1. Or wait. No. This is a finite geometric series, folks. And so what it will be 3,000. You increment the exponent, 2025 for a finite. I was doing an infinite there for a minute. Okay, so you get this. Okay. And then again, y'all, this is just appealing to a finite geometric series formula, and you would get 3 minus 1 down here. Okay? Like that. Okay, so what does this end up being, folks? So this would just be 2, so you can invert and multiply, and your final result will be 2 times 3,000. Excuse me, 3 raised to the 2025. Okay, all over. Let me just write it down here for you. Easier just to write it than talk. Okay. So this is our answer. This is about as simple as we can get it as far as I know. Okay. And again, this is just similar to a problem that was worked by a gentleman by the name of Patrick Lin. He worked this in base 2 back in 2017, I think. And I don't know if, I think he composed it and solved it. And I think it's a nice little problem because, first of all, you got to do quite a bit of algebra to get this in a tractable form. Then even after you do that, at the very end, you're left with something that looks unsolvable. I mean, in terms of writing it nicely. Then you recognize that if you multiply through by the appropriate constant, you end up with a finite geometric series here. So that, to me, that's almost the definition of a good problem if you combine 2 or more so-called deep ideas in the same problem. But anyway, that's the end of the problem. I hope you enjoyed. Thank you for viewing.